Hello, hello, hello. Hello, 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 hello. Perfect. Okay, I can hear myself. Uh, so just carrying from yesterday, I was trying to visualize where the angles were going wrong uh, in my calculation for the climbing hold, and I was going to write or draw a graph just to demonstrate those angles. I don't know if I'll continue with that. I don't know how helpful it's going to be and how much of a waste of time it is, but we'll just start and see how it goes. So without further ado, let's start. Oh, I feel a bit ill. Oof. Okay, so this is where we got to, and I was looking through the code, and I realized I didn't pick up the ray trace. So I've got all these other angles, but I don't know which way the ray trace was coming from. And of course, that's how you do the dot product. I had to remind myself of it, just so you know. I actually went to this channel, Brian McLogan. Um, it was good enough. It was very clear because I think I've done it before. I understood that he was doing the bits and bobs. So that's good. I'm gonna keep it on the side because I always forget. But quite simply, it's 0, 1, or 0, right? So let's just put those in. I was pressing to the left, so the ray trace is going to be x, y, z. So x is backwards. It's going to be 100. Well, it's not actually. It's going to be 0. And then actually that might be the problem. That might be the problem. But anyway, let's carry on. Well, actually, I'm that really could be the problem. Yeah, right. Okay, so where am I? I'm back into here, I guess. Nope, here. And then it's going to be left, so it's -1, and then uh, z is 0. So that's our new coordinates there. And so let's plug those into my thingamabobby. So yeah, so it's interesting, isn't it? Because that I tell you what I'm going to do. I'm just going to do this again, but make sure I've got the offset of the character. Um, because like basically, let me just try and draw it. I think what I've been doing is I send off a ray trace to the left, but actually the let's say this is like top view. Let's say this is top view. The the actual climbing hold is over here, so the angle is going to be doing that rather than just like that. And I wonder if that makes any difference. I suppose it'll make a difference on the x-axis, right? Um, maybe it doesn't matter too much. Hard to tell, really. It's wrong anyway, like it's not what I want. But maybe I don't need to. I'm just trying to think of where the distance comes from. I can't remember now. Distance from character. Distal. Okay, and then only get location. Y and Z. So I'm only, okay. So I'm locking off at 0 anyway. This is for For distance, I'm doing that. Mm, yeah, because I think because I'm actually just getting their location and not setting that to X, I think that could be problematic. Let's oh gosh, it gets a bit difficult now because let's say we've got one climbing hold here and then one over here. So it is going back slightly, right? And so when it's trying to choose, it's like doing it from here to here, and so this one's always going to be closer because it's got this farther to travel, this distance to travel. Okay, well I don't have that problem yet. So let's focus in then. So we're trying to figure out so we've got the ray trace line, and now we've got something to work out our dot products so that we can do the magnitude and the angle between them. So let's plug this in. So it's going to be, oh, what was it again? 010. This is location of A. It's on the x-axis. Y here. Let's just copy that like so, and like so, and this will be B. Okay, so now I can put those in like that. I'll just run it to make sure I haven't marked anything. I haven't, cool. So now I do the dot product, right? So it's going to be, without looking, let's see if I can remember, dot product of ray trace and location of A is equal to you mul no you plus the numbers together. It's the sum of all the x's and the sum of all the y's multiplied together. I think so. So in that case, it's gonna be minus 250 or location of AX 0 plus location of BX 0, and it's all of that divided by, so that's the dot product. I can't remember. Let's have a look at this again. So we've got 4 times 3, 3 times 5. Oh, okay, so it's the x and y values. Okay, fine, let's do that. No one's going to get that wrong. So that's going to be 1. And then divide that by the magnitude, which is the x times the x in the other one? I don't know. So it's going to be a location of b x times. Oh, sugar, you know what? Yeah, yeah, yeah. Okay, so this makes sense. So it's this multiplied by this all divided by, let's try and make this a little bit more attractive. All multiplied by, and then is it times? No, oh, it's the square root. Okay, and have I done that in the equation here? No, I have not. So this one is saying the magnitude is the square root of these squared. So let's do that then, math.squirt. I actually don't know how to do that in see if I can include that. Is it squirt? Yeah, squirt. Give it a good squirt. Location of b, square root of location of bx, is it times or plus? I can't remember the equation here. Plus. Alright. So it's this squared. And let's do a first, and that's going to be 4 and 3 and 3 and 5. So it's across them. So it's going to be this one first, and then it's this one, and then it's all times. Let's kick this onto a new line. Math.square root of b. No, sorry. Y. Y. And this one doesn't look right now, so it's actually this. That's it. Okay. So just to absolutely be clear here, I'm doing the dot product, which is the sum of x and y multiplied by the sum of the other vector x and y. And then the denominator is the square root of the first x and the second x to the power of 2 times the y part, which will give me the angle, actually. Angle between vector A and vector B. Ah, but I didn't want to do that. I wanted to do it between the ray trace, right? So it's actually going to be, that one is kind of irrelevant to us. So if I do then, yeah, that. Well, yeah. And let's start with A, right? So ray trace and vector A. Damn it, I need to go to the toilet. That's so annoying.